API and APIs, crafting the future of intelligent integration at scale. Let me introduce myself first. My name is Marcel Meyer. I'm Senior Solution Architect, Engineer, Consultant, and Teacher. And I'm Technology Lead, and I have the Chair of API Management at Adorsys. At Adorsys, we are working in designing, concepting, and developing applications for governments, for financial institutes, for cities, and we are consulting companies in API management and in API strategies. So a short overview over the agenda. We will have an introduction about what AGI is. And then we will have a look at a variety of APIs today. And we will look at the relationship between AGI and APIs, as well as the challenges and opportunities which comes when we involve AGI into our APIs. We will look at the best practices for the integration of APIs into AGI, as well as the ethical and social considerations. And in the end, we will come to a conclusion and look at the future directions. So when it comes to AGI, there are some differences between AGI and AI. AI are designed for specific tasks or a narrow range of capabilities, whereas AGI, or artificial general intelligence, is capable of applying its intelligence to a wide range of tasks, and especially it can learn new skills without being explicitly programmed for it. Also, AI is a broad term that refers to machines or systems which are capable of performing tasks that are typically require human intelligence, whereas artificial general intelligence represents a future state where AI can perform literally any task which a human being can. When we look to the APIs or the variety of APIs today, there are a lot of APIs in every aspect of the real life. For example, we have navigation and traffic APIs, where these APIs provide real-time traffic data, route planning and navigation assistance. Millions of people rely on them in their daily commuting, traveling, and logistics. We have banking and financial APIs, which allow us secure access to financial data, enabling features like online payment, mobile payment, and personal finance management. Also, we have, for example, smart home and have fabrication APIs, which let us literally control every device in our homes, or which allow us to have completely automated warehouses and fabrications. Another example are the healthcare and medicine APIs, where their APIs allow us seamless integration and sharing of patients' health records, which allow physicians to have up-to-date informations, which are leading to better informed diagnosis and treatment plans. So, as I already mentioned, there's a strong relationship between AGI and API. When we think about AGI and our API development, it comes to, for example, automated development. We can envision an AGI system which is designed for, which can design shopping API overnight, evolving it by the hours as the market trends shifts, which leads to rapid API development acceleration. We have advanced security. You can imagine, for example, an AGI that predicts a new cyber attack pattern and fortifies a bank's API defenses before the threat materializes, which leads to something like a digital chameleons, where an API security can easily and align in real time to new attack vectors. For example, we have intelligent integration, So you can imagine an AGI system which can act as a bridge between different APIs. It can request data from one API, transform the data, enrich it, convert it in real time, and can send it to another API, which leads to a global mesh of services and API. So literally, every API can combine with any other API. We have personalized API services. So you can envision an AGI that curates personalized travel experience by analyzing a user's past destination, preferences, and reviews, which leads to predictive personalization in APIs. We have scalability and performance benefits. For example, if you think about a streaming service API that can effortlessly scaling during the premiere of a popular show without any single glitch. So this leads to seamless traffic search. And last but not least, for example, we could have real-time anomaly detection. You can picture an AGI which identify and isolating an unusual search or like fraud patterns in banking API requests before they even happen, which leads to something like a digital immune system in our API development. As I already mentioned, there's a strong relationship between AGI and APIs. This is because of the fact that APIs act as a bridge for AGI systems. They act as a bridge for variety of data sources. So they give access to a wide range of different data sources, which is really important for AGI systems, especially for their decision making, because the AGI makes the decisions based on the data. But also APIs act as an integration to different systems and platforms and services for AGI, which is necessary to control these systems. So when it comes to a decision for an AGI, it needs APIs to control different services and systems. With this in mind, we can think about some technical challenges for AGI and API. So AGI needs more sophisticated interfaces and data handling mechanism compared to traditional AI systems. We as developers, we have to ensure data privacy and security in such dynamic environments. And also, we have to ensure that our APIs scale effectively while maintaining performance. On the other hand, we have opportunities for the innovation. So we can automate many tasks in the API development, in management, and in integration. With that, we can free up human resources to do some more creative work. AGI can also enable us to develop more intelligent, responsive, and user-centric services. And the AGI can also ensure that our API infrastructures can continue to evolve and adapt so that they can stay relevant and efficient as the technology advances. When it comes to some real case examples for what I have explained, we can, for example, think about healthcare and medical diagnosis. For example, AI systems which are integrated in the healthcare APIs, which helps to analyze medical images to assist diagnosing diseases like cancer more accurate and quickly than traditional methods. We can think about patient data analysis, where AI algorithms can analyze patients' data from various health APIs to predict health risks, to personalize treatment plans, and to improve patient outcomes. In context of financial services, we can think about fraud detection services, where AGI can help our systems integrating banking and financial services that can help to analyze transactions data in real time to detect and prevent fraudulent activities. And for example, we can have personalized banking services where AGI can use data from banking APIs to offer, for example, personalized financial advice, optimize investment strategies, and provide tailored customer services. Another example could be predicting weather patterns, where AI models can help develop meteorological services. HAI can use then the historical data to make some hypotheses and to predict, for example, heavy rainfall. And these systems can be connected and combined with, for example, emergency services. It can be combined with energy management services or flood warning services, flood warning systems. So with these technical challenges and benefits, we need to align our design principle that our API is HAI ready. First of all, we need to ensure scalability and dynamic. We have to handle the dynamic and potentially vast demands of HAI systems. And we have to ensure that we have the ability to manage large volumes of data and requests, because an HAI system has to learn how our API is working, how it can use our API, and it will send a lot of requests. And we have to ensure that we can scale accordingly. Also, we need to ensure a stateless architecture in our API systems. When it comes to security, as the HAI capabilities are growing and an HAI is usually able to use any attack vector which is out there, we have to secure against these advanced capabilities of HAI, which means we have to have a proper update strategy, and we have to have audits on our API systems. We have to keep in mind the sensitive nature of the data, of course, because an HAI system will use any data which it can get. So we as developers are responsible for this sensitive nature of data. And we have to rely on robust security protocols, like, for example, our authentication to be secure, as well as securing the data transmission, for example, HTTPS, and authentication and authorization mechanism. Also, what is important for the design to be HAI compatible, we need to ensure flexibility and modularity in our API design, which means we have to have small APIs with core functions instead of big APIs with a lot of functions, because this leads to easily modifiable and extendable APIs. And when it comes to the design, we also have to ensure that we follow standards like REST and other guidelines, so that the HAI knows by the standard how our API is working, as well as, for example, a consistent API contracts, so that the API is not behaving in a strange way which the HAI doesn't expect. When it comes to legacy APIs, we have to check our APIs for some aspects. For example, for the data quality and consistency, we have to ensure that our data which we provide by the APIs are accurate, consistent, and reliable, because otherwise it leads to wrong decisions in the HAI systems. And on the other hand, we need to have strong data validation, because the HAI system will send us data in any way you can imagine. So we need to have a strong data validation for the data we accept in our APIs. Again, we have to rely on standardization processes, and we need a strict data policy for the data we offer to HAI systems. One thing which is also very important is the necessity of documentation and versioning, because an HAI system will use our documentation to understand how our API is working, what our API is doing, and this leads to the necessity of clear and comprehensive API documentation. And not only like an open API specification, but also how-tos and articles, data schemas, and examples for our APIs, which can be used by HAI. We need a proper versioning practice and update strategy, and we have to ensure that our versions are downward compatible, and also we need an update strategy without disrupting the AGI system. Another thing is that we need to ensure performance and error handling. As I said, we need to have scalability and good performance, because an AGI will send a lot of requests to our API to understand how the API is working. And if it comes to failures, we need a robust error handling, which means we have to handle requests efficiently, and we have to provide meaningful error responses so that the AGI system can understand why the failure happened and how it can solve the failure by itself. There are also some ethical considerations which we are responsible for as developers and API designers. The first of all is the data privacy and consent, which I already mentioned. As the AGI system will collect any information or any data from our APIs which are possible, we have to ensure, or we have to keep in mind, the importance of obtaining consents and maintaining transparency with the data subjects. We have to ensure responsibility and accountability, because now these days you cannot make an AGI system responsible or accountable for wrong decisions. So we as designers and developers, we have to actively participate in creating and adhering these clear guidelines and regulations already also in our APIs. And we have to ensure bias and fairness, because there's a risk of biases in AGI systems which can arise from skewed data sets or flawed algorithms. So we have to have bias detection and correction algorithms in our APIs. And again, we have to integrate audit mechanisms in our API design. So let's have a little short recap about what we talked. We talked about an AGI as a self-learning system, and we talked about a wide range of APIs that can benefit from AGI. We saw that there is a strong relationship because APIs act as a bridge for AGI systems. And we saw that there are challenges and opportunities, like, for example, in security, in performance, and in data handling. We talked about some best practices for designing AGI-ready APIs, and best practices for data handling and API contracts. And in the end, we looked at some ethical considerations, for example, the role of developers and the public in crafting the future of AGI systems. When we are able to solve all these strategies and best practices, there's like a roadmap how an AGI system can evolve in the next couple of years, which starts with the milestone enhanced API automation. We can achieve advanced automation in the API development, in testing, in deployment, using the AI or AGI technologies, and setting up the foundation for the future AGI integration. The next milestone could be AGI-driven security and data management, which means we implement AGI-driven systems for real-time security management and intelligent data integration across diverse API platforms. The next milestone could be full-scale personalization and efficiency, which means we attain a level where AGI can offer fully personalized API services and optimize API performance and scalability dynamically based on real-time data and interactions. And then after these three milestones, we can reach the last milestone, which is then an autonomous AGI API ecosystem, which means we have realized a fully autonomous AGI API ecosystem where AGI can independently manage, adapt, and innovate within the API landscape, possibly even creating new APIs or services as they need it in real time. And thank you for your audience, and let's craft the future of HCI together.